Hello everyone, today we'll do the derivation for energy stored in a capacitor. So we'll let dW be the energy stored, the amount of work done in giving a charge dQ to a capacitor at potential V. So according to our assumptions, dW is equals to V dQ. Now on integrating, the limit is 0 to W, which is equals to integration of V dQ. Now we can write V as Q by C dQ, and here we get dW. Also for this step, as we know, the potential difference is equals to dW by dQ. So dW is equals to V dQ. So W is equals to 1 upon C Q square by 2. So the work done is stored in the form of potential energy. So U is equals to Q square by 2C. Also, we can write it as we know, Q is equals to CV. So we can write it as U is equals to C square V square upon CV upon 2C, sorry. So C and C gets cancelled. So we get half CV square is equals to U. So this is the derivation for energy stored in a capacitor. The next derivation that will derive from this is energy density of a parallel plate capacitor. As we know, energy density is equal to U, that is the energy by volume. So we know U is half CV square and the volume is 1 upon AD, area into the diagonal. So we can write it as half. C can be written as A epsilon naught D, and V can be written as E square D square upon AD. So final answer is the energy density that is represented by UD is half E naught E square. As A and A gets cancelled, this D and this D square gets cancelled from here. This is the final answer. Half E naught E square. This is the energy density. So we have done two derivations here. One is the formula for energy and the second is the formula for energy density. Thank you, and I'll see you in the next video.